Okay, so we just finished this one. So it's the same picture. We're still dealing with this line RT, where S is between R and T, but now we have new values. Now RS is 2x, ST is 5x plus 4, and RT is 32. So we plug that all in, sketch it all out, and then we can set up 2x plus 5x plus 4 equals 32. We're going to combine our like terms again and turn 2x plus 5x into 7x. We're going to subtract 4 from both sides to get 7x equals 28. And then to solve for x, all we have to do is divide both sides by 7. Got x equals 4. And remember, we're going to go back and find RS. This time RS was 2x. We know that x is 4. So we know that RS is 8 units long. Then we are looking at this triangle down here. The instructions say determine what x would be if the segments below are congruent. We set up these equations by setting congruent parts equal to each other. If we know that they are congruent, we can take whatever algebraic expression is assigned to it, set them equal to each other if they are congruent. Now we see our congruency markings here and here. So 3x plus 5 and 5x minus 1, these sides are equal to each other. So we can set up the equation 3x plus 5 equals 5x minus 1. We're going to subtract 3x from both sides, which will give us 5 equals 2x minus 1. Nothing happened to the 5, we're just getting rid of that 3x on both sides. And then we're going to add 1 to both sides, so that we get 6 equals 2x. And when we divide both sides by 2, we have x equals 3. And that's how we solve for x. So down at the bottom, we see this. A postulate is a statement that is accepted as true. Postulates describe fundamental relationships in geometry. So anytime we're talking about a postulate, this is sort of a rule that we can go back to, sort of like when we see these congruency markers and we know what those mean. A postulate is something that we can count on to be true. So here are a few postulates that you're going to run into a lot in geometry. Through any 2 points, there's exactly 1 line. Through any 3 non-collinear points, there's exactly 1 plane. 3 points that are not on the same line. 2 can be, 1 has to be separate. A line contains at least 2 points. A plane contains at least 3 non-collinear points. If 2 points lie in a plane, then their entire line containing those points lie in the plane. Blah. If 2 lines intersect, their intersection is a point. If 2 planes intersect, then their intersection is a line. Remember our warm-up earlier. And if a plane and a line intersect, then their intersection is a point. If a plane and a line intersect, then their intersection is just a point. So these are things that you will normally see, these kinds of statements you'll see next to an always true, never true, sometimes true. If it says exactly this, it's always true. If it says the opposite, or it's off by, like if through any 2 non-collinear points, there's exactly 1 plane, or through any 3 collinear points, there is exactly 1 plane, then it's always false. If you change the statement, then it's false. If it's just a little bit off, like a plane contains at least 3 lines, then it's sometimes true, because we could kind of stretch the definition, but it's not quite there. So these are things you don't necessarily have to memorize, but when you see them, you should be able to recognize them for being the exact postulate or a little bit off. You're never going to have to just like, well, okay. So the only time you would be given like a fill in the blank for this is for these last 3. If I ask you when 2 lines intersect, you should be able to tell me their intersection is a point. you should be able to tell me if two planes intersect, that their intersection is a line, and that if a plane and a line intersect, their intersection is a point. These three you might see just phrased like, if two planes intersect, what is their intersection? So those three, be especially careful with. Postulate is always true. If it's the opposite of the postulate, it's never true. That's the most common question you'll see. All right, so on the next page, we've got one more page to go. You're almost there. At the top, you want to define these three words in your, these three terms in your own words. These two, or this one we've already talked about. These two, this one you should be pretty familiar with, and this one you should be able to extrapolate from this one. So pause the video, try that on your own really quickly, and then come back. So I would say that parallel lines are lines that never intersect. Skew lines are lines that are not coplanar, not parallel, and don't intersect. And parallel planes are planes that never intersect. That's how, those are my own words. So if you want to use those to create your own words, that's fine. So then we're looking at these questions next to this diagram. What plane is parallel to NOP? Well, there's only one plane that doesn't touch that ever, and that's plane UTS. UTS down here. So the top is parallel with the bottom of the box or prism. So then we want to say what segments are parallel to RS. Well, since it's part of two planes, we can find two parallel segments, MP and UT. Those are the segments parallel to RS. What segments intersect plane MNU? MNU, that's this one. So the segments that intersect it, that are not contained by it, are MP, RS, UT, and NO. Those four segments intersect the plane. Oh, and SM right here. This one right here. So those intersect the plane. They're not on the plane, but they intersect it because they come to those points. What segments intersect line UT? Again, there's four. There's ST, there's OT, there's NU, and there's RU. Those four intersect line UT. And the segments that are skew to PS, remember skew is not parallel and not coplanar, so nothing that intersects it, those four lines are out. Nothing that it's parallel with, not this one, because it's coplanar. And it intersects it. So our other choices are NU, NO, UT, UR, and UM. These five right over here that are not on the same plane, and they will never intersect it. Okay, one more video, and then we will be done, and the next one should be pretty short.